It may be puzzling to some that we possess the capability to detect exoplanets situated at astronomical distances, with some lying hundreds or even thousands of light years away from us. Yet, there remains a conspicuous absence of evidence for the existence of the elusive Planet 9. For the uninitiated, Planet 9 is a hypothetical, massive celestial body that certain scientists believe exists in the outermost regions of our solar system. It is theorized that the planet has a mass of approximately 5 to 10 times that of Earth and possesses an extremely elongated orbit that carries it as far as 20 times the distance of Neptune, the farthest known planet from the Sun. The idea of the existence of Planet 9 came about due to observations of certain objects in the outer reaches of the solar system, such as the trans-Neptunian objects and sednoids that have orbits that cannot be explained by the gravitational influence of the known planets alone. Therefore, scientists propose that a yet-to-be-discovered massive planet may be responsible for these anomalies, exerting its gravity on these objects' motion. If this is true, it would suggest that Planet 9 occupies an extremely elongated, egg-shaped orbit, completing one revolution around the Sun every 10,000 to 20,000 years. To put its orbit in perspective, Neptune orbits at a distance of 2.8 billion miles from the Sun and completes one orbit in a mere 165 years. And orbiting at such a distance from the Sun would render the planet incredibly faint, approximately 6,250,000 times dimmer than Uranus as seen from Earth. Although there are a multitude of asteroids of similar dimness, they are distinguishable due to their rapid motion across the sky. In contrast, Planet 9 would move at a very slow relative velocity to Earth, making it extremely difficult to differentiate it from just another dim star. Sure, one idea is to use super-advanced telescopes like the Kepler telescope to find Planet 9. But telescopes don't work that way. Telescopes detect exoplanets by observing the small eclipses that happen when they pass in front of their star. Planet 9, if it exists at all, won't do that. Scientists would have to find it against the blackness of space by detecting the tiny amount of sunlight it reflects. It's like trying to find a needle in a haystack, but instead, the haystack is in space, and you're given a pea shooter to search with. And to make it even harder, you're doing it while spinning around like a top. That begs the question, how does one go about discovering Planet 9 in the first place? If I were to show you an image like this one and ask, "Can you see a planet here?" you'd probably say, "Yes, that's Earth down there." But other than that, you might not be able to spot it. You may have already guessed what scientists go through. Therefore, it's truly remarkable that early human astronomers were able to differentiate between stars and planets more than 4 millennia ago, utilizing nothing more than careful observation. By meticulously observing the night sky on a regular basis and creating intricately detailed star maps, Babylonian astronomers were able to chart the motions of celestial bodies and determine which were orbiting within our solar system and which remained relatively fixed in place. Stars, being at such great distances, should not appear to move, in contrast to the planets, which lie much closer. Not a bad piece of deduction. But this method of observation, even with today's technology, can only identify planets that lie closer to Earth. Efforts have been made to detect the heat signatures of Planet 9 using infrared telescopes, but thus far, the search has come up empty-handed. Scientists ask themselves a logical question. What kind of object would have enough mass to change the orbits of other celestial bodies, yet not be visible to us? There is an idea that Planet 9 could potentially be mistaken for a primordial black hole, which would exhibit similar effects. Although it's purely hypothetical, as we haven't detected any primordial black hole yet, at the very dawn of the universe, when everything was much denser and hotter, primordial black holes popped in and out of existence within just a second. And depending on when during that second such a black hole was born, its mass could have been as little as 5 to 10 grams or as enormous as 100,000 solar masses. The thing is, if our calculations about an elusive planet's mass are correct, a primordial black hole, a few times the mass of Earth, would only be the size of a grapefruit, or even smaller than a human fist. And if that's the case, we have no chance of finding it with a telescope ever. Let's also remember that black holes are also infamous for their gravitational pull, making them among the most destructive celestial bodies in the known universe, from which even light cannot escape its gravitational effects. But even if a primordial black hole does exist at the edge of the solar system, there is no cause for alarm, as Earth is not in danger. Primordial black holes are too small and weak to cause any significant harm to our planetary system. But what made astronomers come up with the idea of primordial black holes at all? For one thing, it was an inexplicable brightening of stars, as if some massive but almost transparent object was passing in front of them. What's more, these stars not only started to shine brighter for a brief moment, but they also seemed curved, as if you were looking at them through a giant magnifying glass. Furthermore, when scientists created a computer model of a primordial black hole 5 to 10 times as heavy as Earth and with an orbit distant from the Sun, the results were intriguingly similar to the events occurring in the region of the Kuiper Belt. Too much so to be a mere coincidence. And finally, a primordial black hole would explain why hypothetical Planet 9 can't be seen and doesn't produce infrared radiation. There's also a wild theory that Planet 9 could be a brown dwarf, a star that is not massive enough to sustain nuclear fusion in its core and emit light. The ideas and possibilities are endless. Perhaps somewhere, a photograph of Planet 9 already exists, but has simply been misidentified as a star. With so many billions of stars to keep track of, and with Planet 9's 10,000-year orbit, It would be forgivable if it took a few years to notice that one star was not in exactly the same place it had been when it was last photographed. Those searching for Planet 9 have bet their hopes on a new generation of telescopes, one of which, the Vera Rubin telescope, is currently being built in Chile. As part of the Legacy Survey of Space and Time project, it's scheduled to begin operations in the fall of 2023. This is going to be an 8.4-meter or 27.5 feet telescope with a 3200-megapixel camera on board. The camera, the size of a car, is going to be the largest camera constructed for astronomical purposes. With such a tool, scientists could not only verify if Planet 9 actually exists, but also find roughly 20 terabytes worth of space objects and other phenomena in one night. Just in a year, the observatory will be able to capture more of the cosmos than all the telescopes on Earth ever did combined. This can turn our perception of the universe and our place in it upside down. Or maybe the James Webb Space Telescope, which offers unprecedented details of the infrared region of the cosmos. It's a tedious job. The planet is shrouded in mystery. But despite this, its allure is undeniable, drawing in only those who dare to uncover its secrets. Of course, the ninth planet might not be there at all. And while the jury is still out on what exactly exists out there, we can say for certain that with the advancements we've been making in technology and with the determination of astronomers worldwide, someday we'll hit the final nail in the coffin of this mystery.